Hi everyone, this is Adam again. So today I'm going to go over injective, surjective and bijective functions. So just what do they mean, and if it comes up in an exam asking you for the test for these certain things, what do you do? Okay, so first of all, a function is called injective if all outputs are unique. Okay, so injective is basically just saying, okay, if I get an output, there's only one way to get that output. So an example of an injective function would be something like this. Okay, the y equals x line. Because so remember, an input is what you put in. So x is what you put in, and the output y is what you get. If I do this thing called the horizontal line test, it's basically, you just put horizontal lines, and for a function to be injective, you can only hit the graph at most once. So here I hit it once, 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 and here I hit it once. And if I keep doing this forever, I'll only ever hit it once. So this would be called an injective function because all the outputs are unique. Now you might say, okay, well, in what case would all outputs not be unique? Something like y equals x squared. So for y equals x squared, if I now do my horizontal lines, this would not be injective. Why? Because here it hits it twice. Okay? And basically the physical representation of this is basically if I say x is equal to 2 or x is equal to minus 2, then y is equal to 4, y is equal to 4. So basically, if y equals x squared, then there's two ways of getting 4. I can plug in plus 2 or I can plug in minus 2. So therefore, the output isn't unique. So that's what we mean by injective. So injective is just, are all the outputs unique or are they not unique? Here they are unique for y equals x. Here they are not unique. Okay? So now the next one is surjective. So surjective, it just says that all outputs are hit or used at least once. Okay, so basically if I ask you for some sort of function, I can just say, okay, can I get a 2? Can I get a 7? Can I get a 3.2? Yes, you can do all these sort of things, okay? So another one that would be surjective is again the y equals x line. So now if I do my horizontal line test, basically here, you need to hit the graph at least once, okay? And here I hit it exactly once, okay, for all of them. So this is all it's saying it's saying that you have to hit the graph at least once, okay? So it doesn't matter if you hit it 20 times or 30 times, you just have to hit it at least once. So now, an example of a surjective function would be something like this. Okay, I'll do an example in a second, but let's just say this is the y equals x squared, and I'm only looking at the top half of the graph. So I couldn't care less about any of this. Okay, so I'm only looking at the top half. So here, you can draw your horizontal lines anywhere. Now I'm only drawing the horizontal lines in the top half of the graph. So if I draw a horizontal line here, it hits the graph once. If I do it here, it hits it twice. If I do it here, 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 it'll all just hit it twice. So this would be an example of a surjective function where you hit the graph at least once. But just to make sure, this one is not injective. So injective is you hit the graph at most once. Surjective is you hit the graph at least once. So in this case, this one would be surjective but not injective. Okay? And then bijective is basically when it's both. Bijective is just when it's surjective and injective. So this is when all outputs are used and none are shared. So that's basically what bijective is. So it's basically surjective and injective kind of combined. So an example of a bijective function would be the y equals x line, or basically any linear function for that matter. Why? Because this basically says that you need to hit the graph exactly once with all your horizontal lines. And so I hit it exactly once every single time. Okay, and therefore this one is bijective. Okay. So yeah, that's the definition of those. I might do one more example. So it's also very important that in these questions, they'll specifically say, okay, only looking at this. So it's like f maps x to say x squared, and it maps it from the positive reals to the positive reals. Sorry, from the reals to the positive reals. So what this basically means is, this means that you graph your y equals x squared, but you only graph it for greater than 0. Sorry, that's less than 0. Greater than 0. Because this is r positive, which is basically saying that x has, or y, more so, sorry, let me get rid of that. That y is basically has to be greater than 0. Okay, so that bit, what this thing basically tells you, it just tells you that you can't draw your horizontal lines down here. So you can't do this. That's not a thing. Okay, so you can only draw them up here. Because let's say we didn't have this, and I didn't have the plus there, and I could draw my horizontal lines, then this wouldn't be injective because I hit the graph here twice. So remember, injective is you hit the graph at most once. But it also wouldn't be surjective because here, for this line, I don't hit the graph at all. And therefore, sometimes I hit it twice, sometimes I hit it once, sometimes I hit it 0 times, and therefore it's not injective or surjective, and therefore it's obviously not bijective either. Okay, but if they do say that it's R plus, then that basically means that you can't draw these lines down here. Okay, and then in this case, it would be surjective. All right, so just to be careful of that. Okay, very last thing is, how do you calculate inverse functions? So an inverse function is basically, if you do one and then the other, you get back to the same thing. So this is the thing that I said a while ago. It's basically, if you do f of g of x, you get x. Or you do g of f of x, and you get x. So this implies that g is equal to f minus 1. So the minus 1 up here, this means inverse. Okay. So now, if I asked you to calculate, so hopefully it makes sense why it's the inverse. So an inverse is just something that undoes it. So it's like, if I give x to g and g does something to it, it changes it, it could do whatever, and then you give that to f. F is called the inverse function if it undoes what g does. So if it undoes what g does, then you'd expect that it would give you back x. So I start with x, I give it to g, you give it to f, you get it back. If it undoes it properly, then it should be x. So that's kind of like, say, I have a pen. I give the pen to, say you have Francis and Gary. So I give it to F, so I give it to Francis, and then Francis basically takes the pen apart, and it's all in its different parts, and it puts it down on the table. If Gary is the inverse, or he's the undoer of what Francis just does, then what will he do? He'll put the pen back together. So whatever Francis did by taking the pen apart, Gary will then put the pen back together, and then when he gives it back to me, what am I left with? A pen. So I give Francis a pen, and then Gary gives me back a pen. So that's why it's this condition here, that if you give G x, and then you give that answer to f, you get back x again. So now, how do we actually calculate these inverses? So let's say you have f of x is equal to 3x plus 1. How do you calculate the inverse? Well, the very first thing you do is you equal it to y, just to make the algebra a little bit easier. So you have y equals 3x plus 1. You now want to write this as x equals ... So you want x equals something, okay? So I'm going to bring the 1 over and get 3x equals y minus 1. Divide both sides by 3, I get x equals y minus 1 over 3. This is the thing that you want. So f minus 1, the inverse, is just equal to, wherever you see a y, just replace it with an x. And that's it. That's now the inverse. So the inverse of this is this. Okay? And let's see, is that the case? So let's plug this in here for x. We get, it's going to be 3x plus 1 minus 1 over 3. That's equal to 3x over 3, which is equal to x. So that's the inverse. Now again, let's say we plug this into this one instead. We get 3 times x minus 1 over 3 plus 1. That equals x minus 1 plus 1. That equals x. So we found the inverse. Okay? So that's how you get the inverse. You just write it like this, and then wherever you see a y, you just replace it with an x. And boom, you're done. Okay? So that's it. All right? So, yeah, I think we can leave that there for functions. And then the next video will go over probably patterns. Yeah, number patterns and sequences. All right, perfect. I think I'll leave that there for today. So thanks very much for listening, and I'll let you off with that. Thanks.